In this video, we're going to talk about jump start procedures and what you as a mechanic should do to troubleshoot the system after you've jump started a unit. Now, when you get called out on a road call or if you're out in the lot to jump start a unit, the common idea is that an accessory was left on or a light was left on, which depleted the batteries and causing the need for a jump start. But you don't ever want to jump start a unit and assume that the system is good and it's going to keep on running. You should have a troubleshooting process in place to make sure that the charging system and the cables and the batteries are all good. So a common myth is that after you've done a jump start that the alternator will charge up those batteries. Well, that's not necessarily true. Depending on the state of charge of the batteries, if let's say they're 25% or 50% state of charge, that alternator could take up to 2 or 3 days of continuous running to bring those batteries up to full state of charge. So the primary job of the alternator is not to charge up those batteries, it's to actually run all the electrical accessories in the truck while the unit is running and maintain the charge on the batteries. Another common thing that happens is you can have poor connections at the batteries or the starter or the alternator. So while the unit is running, all the amperage can't actually make it to the batteries and maintain the charge. So you could already have a low state of charge batteries, and then if you leave an accessory on top of that, it's just going to deplete the batteries. So in this video here, we're going to outline some troubleshooting processes, so follow along as Luis shows you and demonstrates what you should do in the case that you have to jump start a unit.
Okay, so today I'm going to walk you through the steps on how to perform the jump start process. What we first want to do when you approach the vehicle is you want to go ahead and inspect the batteries. We're going to look for any loose connections, cracks, leaks at the battery, any swelling or an awkward smell coming from the batteries. That's letting us know that those batteries are shot. We want to make a note of that. That way when we further evaluate those batteries, we have that in mind. So the first thing we're going to do is we're going to remove the cover, inspect the batteries, and then move forward with our jump start. Okay, so the batteries are good. They don't look to be leaking or they're not cracked. The connections are good. So now we could go and move forward to perform our jump start. Alright, so we're going to go through the process now on how to perform the jump start. Alright, so the next thing we want to do is we're going to go ahead and hook up our jumper cart cables to our remote post here on the frame rail. Now sometimes this could be on the passenger side, as it can also be on the driver's side. In this case, we're on the passenger side. So what we're going to go ahead and do first is hook up the B positive cable from the jumper, and then we can hook up the negative cable. This will prevent any arcing or shorting of the unit, so we want to go ahead and do that first. So let's take our B positive cable and hook that up to the stud. Alright, so once we've done that, now we can go ahead and move forward with performing our jump start. So if you do have a remote clicker, you will have to engage that while you're cranking the unit, and that way it can send all the power from the jump cart to our unit. If you don't have a remote clicker, you can go and start the unit up. If that works, great. If it doesn't work, then also you can attempt to hook up an additional jumper, or you can actually make these same connections but at the battery. Now the other thing you want to go ahead and do is once you're done with the jump start and you want to remove your cables, you want to go ahead and remove them in the exact same reverse order as you install them. So we're going to go ahead and start by removing the ground cable first, and then we'll remove the positive cable. Alright, so now once we've removed our cables from our jumper and our unit's running, we want to go ahead and bring our unit into our shop to perform that further evaluation of the starting and charging system. So at this point, we want to advise the driver, hey, we got to bring this unit into the shop, and once we do that, we can go ahead and perform those additional steps and testing. Alright, so once we've brought the unit into our shop, the first thing we want to do is perform a battery pack test with our IntelliCheck tester. Now this is going to check the bank to see if it has sufficient state of charge to start the unit. We want to make sure that those batteries are as close to 100% as possible before we move on to testing the starting and charging system. So let's go ahead and take this side step off, get some access to the batteries, and perform that IntelliCheck bank test. Alright, now using our IntelliCheck tester, we're going to go ahead and perform our bank test. So let's go ahead and start that. Go through the prompts through the IntelliCheck. Now here you're going to go ahead and select bank test. Select the number of batteries. Here we got 4 batteries. We're going to select 4. Inspect for any dirt, leaks, cracks. We want to always do that when we're looking at the batteries. Now we're going to connect our large leads here. We want to make sure that when we connect our battery leads, we go across the bank. So the furthest connection on one side to the other. Alright. Make sure you enter what type of battery it is. If it is a flood type battery or an AGM, get the right selection. And then state the single battery cold cranking amp. Alright, so in this case here, we got a test separately, and we could see the current state of charge is currently at 50%. So what we want to go ahead and do before we start charging these batteries, we actually want to break out the pack, check all the connections, retorque them, make sure that all of our connections are secured, and re-perform this bank test. A loose connection could give you a false state of charge too. So let's go ahead and inspect those battery connections, torque them 10 to 15 foot-pounds, verify those connections are good, eliminate any corrosion or any debris that may be on those batteries, and go from there. Alright, so once we've already verified the connections on our cables going to the batteries and the connections at the battery, we can now go ahead and retest that bank and see what the state of charge is now. So once again, we're going to go ahead and hook up our cables across the pack. So once again, we'll go right through the prompts. Now you can see once we've retested with good battery connections, we still get to test the batteries separately, but it did change the state of charge. Now it's showing 56%. So we still have to break these batteries apart and test them individually. But one thing you always want to know is that loose connections will change the reading on the state of charge. So verify the connections and retest the bank. So right now we're going to go ahead and break apart these batteries, and we're going to go ahead and test these batteries separately. Alright, so once you got the batteries broken apart, you want to go ahead and use these lead or brass adapters to the top post of the battery. That way you have a solid connection as you're testing them individually. So let's go ahead and put those on. Alright, now here we can see that on this test result, we got a good battery but needs charge. So right now it's showing the state of charge is at 61%. The cold cranking amps are up, they're at 820, and these are rated at 730. So that's good. Now we just need to charge this battery. Let's go ahead and do the rest of the batteries exactly the same. Alright, so after performing the battery test individually, we did find one battery that was marginal battery. That's letting us know that the battery will not hold charge, it's not a good battery, and we should replace it at this time. So we're going to know that we're going to charge the other 3 batteries. These were at 65%. We would hook up to the battery charger, test them after we charge them up to 100% state of charge. Those pass, and we just got to replace one battery under warranty if the warranty applies. Alright, so once we got a good set of batteries in here, they're charged up, they're as close to 100% state of charge. Now we can go ahead and perform the voltage drop test for the starting and charging system. So what we have to do is we're going to use our IntelliCheck tester once again, but this time we're going to go into the V-drop menu and perform the charging system voltage drop test and also the starting system voltage drop test. So in order to perform that, you'll need the IntelliCheck tester along with the extension cables that will be connected remotely. So let's go ahead and go through that process. Alright, so in order to perform that voltage drop test, you're going to need the extension cable for the IntelliCheck, your IntelliCheck tester. Now you always want to set up your extension cable into our IntelliCheck tester first. That way we don't arc any terminals once we connect them to the battery. So let's go ahead and place those in the socket below the IntelliCheck tester. We're gonna start our IntelliCheck tester. From here we're gonna go down to V-drop menu. And now we're going to perform the charging cables voltage drop. So let's go through the prompts. You got to select the alternator output rating. So in this case we have a 240 amp alternator. We're going to select 240. Now it's prompting us to connect the large leads to the alternator. So let's go ahead and do that. Alright, so once we've hooked up our large leads to the alternator, we can continue through the prompts. Now it's asking us to connect the small leads to the battery. So I'm going to go ahead and do that. Alright, so once we've hooked up our small leads to the battery, now we can go ahead and select continue. That's going to load test the circuit. And what we want to see is the results of the voltage drop being caused on the positive side and on the negative side of the circuit. Combined, it should be no more than 0.5 of a volt or half a volt. So in this case we got 0.22 on the positive side of the circuit and 0.22 on the negative side, and it's testing as good up to 273 amps. So that lets us know we have a good connections from the batteries to our alternator. Alright, so once we've completed our charging system voltage drop test, now we want to go ahead and perform the starting system voltage drop test. So we're going to test the starter main cables now, and we're going to select and go through those prompts. So now we want to connect the large leads to the starter now and leave the small leads at the battery. So let's go through that process. Alright, so once you've made your connections at the starter, now we can go ahead and follow through the prompts of that starter main cable voltage drop test. So our large leads are connected to the starter, our small leads are connected to the battery. And we can see here we're actually under spec. It's showing 435 amps are flowing through those starter cables. We want to be at a minimum of 500 amps. And the reason being right now is that we have a voltage drop on the positive side of the circuit of 0.27 and on the negative side of 0.30. Now that could be caused by poor connections or corrosion in those circuits, so we'll want to inspect that first. But then again, we want to make sure that it's no more than half a volt or 0.5 of a volt. That's the spec combined. Now once we've fixed that and we know we have good connections, we know the circuits are good, now we can go ahead and move forward to perform an alternator output test. Let's go ahead and do that. Alright, so now we're going to go ahead and perform the alternator output test using again our IntelliCheck tester. So the first thing we want to do is from the main menu select alternator. Now from here it's going to take you through a series of prompts to inspect the belt and key components inside of that charging system. So first thing we're going to see is the belt. We're going to check the tension and verify that that's good. So let's go ahead and do that. Alright, so once we've inspected the belt, we know it's good, there's no damage to it, and the tension was good. Now we can go ahead and continue. Next, we're going to inspect the cables and connections at the alternator. This can include the B positive and the negative cable, along with any other connections at the alternator. Alright, so once we've inspected the connections at the alternator and those are good, now we can go ahead and continue. Next, we're going to go ahead and connect our large leads to the alternator. Now once we've connected our large leads, the next step is we have to select what the alternator output rating is. In this scenario here, I have a 240 amp alternator, so I'm going to go ahead and select that. The next question here, it's letting us know, does this have remote sense? So in this scenario, it does have a remote sense wire at the S terminal. So we want to go ahead and Select yes. Now it's prompting us to use our small remote cables. Again, we're going to go ahead and place the red lead on the S terminal, or that sense wire, and the negative lead on a ground. In this case, I'm going to use the ground stud. Once you've connected your sense wire cables, now you can go ahead and continue. Now the next question is, does it have J1708? We're going to select no. This unit is not equipped with 1708. Now we're going to go ahead and perform the alternator output test following the prompts as it's stated in our IntelliCheck tester. First thing it's going to have us do is we're going to start the engine, then it's going to have you rev it up to governed RPM. Once it's revved up, then we can continue and it'll perform the alternator output test. After that, we'll get a result. Go ahead and start it up. Alright, so upon completion of that alternator output test, we will get a test result letting us know if we have a good or bad alternator. It'll let us know what that voltage was regulated at. In this case, it's letting us know that it's at 14.15 volts. That lets us know that our alternator output is great. So from here, we know that our charging system has passed. If we need to, we can go ahead and move forward into performing that parasitic draw test. If we suspect that we have a component inside or in our unit causing those batteries to drain.
To perform the parasitic draw test, make sure the ignition key is in the off position and verify that all the doors are closed. Disconnect all the grounds from the battery and secure them together with a nut and bolt. This will merge all of the current flow through one point in the ground circuit. Place a fused jumper cable in series between the ground cable and the negative battery post. This 10 amp fuse will act as a test dummy to protect the 10 amp fuse inside the DMM. So if the fuse in the jumper cable does not pop, it means it's safe to use your DMM. Next, verify that your test leads don't have high resistance. Anything over half an ohm is a concern. Then move the red lead to the amp jack and move the dial to the DC amp setting. Then place your leads in series to the ground circuit and remove the fuse jumper. The maximum acceptable amp draw on a Swift tractor is 2.5 amps. Anything over that should be diagnosed.